What is sterilization? So, sterilization, as I mentioned earlier on, is a process to remove or destroy all viable life forms. So, it's a process, okay? So, the aim of this process is to remove or destroy microorganisms, spores, or byproducts of the microorganism. So, why is byproducts is important? Because some byproducts of the microorganism can cause a fever. Although the microorganism itself is not present, the byproduct can cause fever or any other problems in the patients. So how can we do sterilization? There are different methods available. So the different methods will be suitable for different types of products. So we have heat-based, non-heat-based. So we can also do it terminally or non-terminally. Terminally sterilized means the process is the sterilization process is conducted after the product is being transferred into the bottle or the final packaging. But non-terminally sterilized means the sterilization happens before packaging happens. So these are different types of sterile products or sterile dosage form. So we have, as an example, we have gauze. Okay, gauze is also sterile. It's individually packed in a sterile package. So in such a case, the gauze is already packed in the final packaging before they are sterilized in the sterilizer. Okay, we also have eye drops, water for irrigation, and also vial and ampoules. So these are example of sterile dosage forms. The sterilization process for each of these products are different. It depends on the active ingredient, whether they are stable under heat or not, and also it depends on the form or on the material of the final product. So as an example, liquid-based product can be sterilized through moist heat, but materials such as syringes or gauze, we can't use moist heat sterilization because the moist or the water present during sterilization will damage the material. So this will depend on the material and also the process. This is one of the important things that you have to understand regarding the kinetics of microbial inactivation. So the inactivation of microorganism will depend on the microbial survival log curve. BP or British Pharmacopoeia gives a guideline on the necessary level of effectiveness. So the BPSAL or sterility assurance level was set at least 1 × 10⁻⁻⁶. It means that following sterilization, the level of microorganism present in a product must be less than 1 × 10⁻⁻⁶. And this will correspond to the overall meaning, which refer to at the end of the sterilization process or sterilization time, a probability of not more than one viable microorganism survive in 1 million sterilized product. It means, what does it mean? If you sterilize 1 million product or 1 million bottle of products, there should be at the most only one microorganism survive the process. Okay, in the 1 million bottles or 1 million product, only one microorganism survive the process. So this microorganism, this one microorganism is allowed to be there, but this also means that the process has to be very efficient to prevent the presence of more than one viable microorganism. Okay, so as an example, if you refer to the microbial survival log curve, okay, if you refer to the microbial survival log curve, the process of reducing the number of microorganisms from 10 to the power of 5 to 10 to the power of 4 is called one log curve. One log, okay? The reduction from 10 to the power of 5 to 10 to the power of 4 is called one log. So how long does this take? For this particular microorganism, it will take approximately 6 minutes. So in 6 minutes of sterilization process, the microorganism will be reduced by one log from 10 to the power of 5 to 10 to the power of 4. So if you want to reach 1 times 10 to the power of minus 6, you have to go 1, 2, 3, 4, 4 plus 6. So at least 10 times log reduction. Okay, 10 times log reduction to achieve 10 times 10 to the power of minus 6. So this is the equation. You don't really have to memorize the equation, but you have to understand what is this equation all about. Okay, so the microbial survival log curve can be represented by this formula, in which N naught means the initial number of organism, this one, and T is the number of organisms surviving after the exposure time, T is the exposure time, and D is the microbial death rate. So T is the time, T is the time is 12, okay, the time is 12, 0 to 12 minutes, but the D is the rate, okay, the rate is 6. So several factors can be calculated from this graph, which is the death rate, okay, and the death rate constant. So, and also we can also calculate the IF, which is the inactivation factor. The inactivation factor is 10, T and D, which means that D is the D value for the organism under the sterilizing condition, and T is the time of exposure. So as an example, the IF for this microorganism is 10 to the power of 10. It means that the number of microbes will be reduced. If we want to reach 1 times 10 to the power of minus 6, we need 10 log cycle. Okay, this is an example of calculation that you can try yourself. And before I end this lecture, so I would like to introduce to you that there are different types of sterilization. We have heat-based and non-heat-based. The heat-based can be divided into dry heat and moist heat, while the non-heat-based, there are 3 types of non-heat-based sterilization that we will cover in this topic. Okay, so that will be all. We will continue with our second lecture on the principle of sterilization, focusing on the heat method of sterilization. Thank you.